Okay, now let's look at number 5. Number 5, we're going to be actually sketching the graphs by hand. And there's many examples that you could do, different variations, and I'm only going to show you one for each of these graphs. So it says, sketch a possible graph for each function described below. So let's first notice that the polynomial function is of the degree 2. So it's going to be an x squared of some kind. And it has a positive leading coefficient. So it's going to have a positive 1. And it could have a positive 1, it could have a positive 2. As long as it's positive, that's what we care about. Okay? So let me highlight this the same color so you can see me progress through this problem. So positive leading coefficient is going to be there. And the degree is going to be of 2. So it's going to be to the second degree. Now we know that this degree of 2 says that it will have 2 x-intercepts, possibly. Okay? So it could have 2 x-intercepts. And then furthermore, we know that 2 minus 1, or whatever this number is as a degree, minus 1 can show the changes of direction. So it can have up to 1 change of direction. So if I'm going to draw a quadratic, in this case, this is a little bit fundamental because we know what a parabola looks like, but we have to make sure that we're cognizant of the fact that it's a positive leading coefficient. So this positive leading coefficient means that as I go to infinity on x, the graph is going to go up. Okay, so it's going to go up toward a positive infinity for y. So as x increases to infinity, the function, wherever it goes, will also increase by going upward to infinity. Okay? So now let's look at another important detail is because this number is an even number, that means there's going to be a symmetry about this graph. So because it goes to infinity as you go to the right, again, because this number is an even 2, it will do the same as you go to the left. Now, if this was a 3 or 5, we'll see how that changes and what that will do to your graph here in just a bit by comparing and contrasting all of these other graphs after we build them. So, with this evenness to it, 1 change of direction and 2 x-intercepts, we can see this is a good possibility. Okay, so let me highlight these as I go. 2 x-intercepts will be shown here. 1 change of direction can be shown here. The fact that this is a positive coefficient means that it will go up as you go to the right. And last but not least, I'll highlight it in purple. The fact that this is an even number says it will do the same as what the right side of the graph did. As far as if they both go up or if they both go down, basically reflecting a mirror image, if you will. Okay, so let's move on. The next one looks at a 4th degree polynomial. So it's going to be to the power of 4, and now it has a negative leading coefficient. Now I can have a negative 1, but I could also have a negative 3. It doesn't matter, just the fact that it's negative is what's important. Okay, so now let's initiate this problem as far as 4th degree says it could have 4 x-intercepts. Okay, 4 x-intercepts could be possible. Okay, so it could even have less than that. So it's just up to 4 x-intercepts because it could have still zeros that are imaginary. So they can still be answers, if you will, but x-intercept wise, they don't have to cross the x-axis for it to be to the degree of 4. Okay, and those are what those imaginary possible roots. Changes of direction. We know that it's always at max 1 less than what the degree is. So we could have up to 3 changes of direction. Okay, and now we can go ahead and start working through this as far as how we're going to draw it. What I would look at primarily in the order that I usually do this in is that I look at this negative leading coefficient. That means as I go to the right, it will nosedive downward. In other words, it's going to go to negative infinity. The next number that I look at is the fact that this is an even number. So there will be an evenness to this. Okay? Just like it was going down as it went to the right, it will also go down or go to negative infinity as I go to the left. Okay? The fact that I have a 4 here says that I could have four x-intercepts. Basically 4 places where it goes through the x-axis. And then, last but not least, I could have 3 changes of direction. So let's draw something that has 3 changes of direction, but actually goes through the x-axis 4 different times. Okay, you have 4 x-intercepts highlighted in blue. You have the 3 changes of direction that are here, here, and here. And you, again, have this negative leading coefficient. The fact that it's negative is what you're looking at. And then last but not least, just reaffirming that we drew something correct. This 4 is an even number, so that means it would have an evenness to it as we went to the left. And that could be a possible graph for what you're looking at right here. Alright, just a little extension on this. I could have, if I wanted to, taken this graph, and instead of going below the x-axis, I could have done something that looked like this, bounced off the x, and went down. It still would satisfy the negative coefficient. It still would satisfy the 3 changes of direction. And yes, it would still satisfy the fact that there are 4 x-intercepts. We could see one here like at negative, let's say 4, here at positive 4, and then one at 0. And I want you to see this would be x squared because it's a double root because it bounced off of the x-axis. So this double root would bounce. That's why I could put a 2. I could put a 2, I could put a 4, I could put a 6. I'm going to show you why the 2 is what the only answer would be on this one. So positive 4 will give me a binomial factor of x minus 4. And x equals negative 4 will give me a binomial factor of plus 4. And like we said in the previous problems, this is where it's the opposite. And if you count them right now, x to the power of 1, x to the power of 1, and then x to the power of 2, adding all of those powers would result in 4. So that's why in this case, it wouldn't be like x to the 4th or x to the 6th or so on and so forth, any other even number. It would have to be 2 because we have 1, 1, 2 for a total of 4. Okay, so little variations on that. Just extension for you to prepare well for the test. Now we have a cubic polynomial, so I'm thinking x cubed of some kind, with the negative leading coefficient, so we could put a negative there. So I concentrate again first on this negative coefficient. That means I'm going to dive down as I go to the right on the x-axis. Okay? And the second thing that I look at is the fact that this is an odd number. Because it's an odd number, it will not have an evenness to it. It will have this diagonal relation showing that it's going to be odd of some sort. Okay? And then I can look at the fact that there are 3 possible x-intercepts, and always it's that x-intercepts minus 1, so that degree minus 1 will show us the possible changes of direction, in this case 2. So I can show something that crosses through the x-axis 3 different times, has 2 changes of direction, and has a negative leading coefficient. So this could, in fact, work. And just for extra practice, let's say that this one went through at 0. We'd have x is equal to 0. We could have x is equal to 3. And we could have x is equal to negative 3. So it would look like x plus 3, x, and x minus 3 as far as multiplied out binomial factors. Okay? This is one example, but with this negative coefficient, I wanted to give you a little bit extra practice with recognizing it. This negative coefficient would actually be out here to show that as you went to positive infinity, it would dive down to the negative realm. Okay? So this is a possible, yes, there are other variations, just like I showed you with this other one where it was bouncing. You could do variations, but the big parts are that it's negative, so it's diving down, that there are a possibility of 3 x-intercepts, and then 2 changes of direction. And last but not least, just want to make these videos thorough because these are the fundamentals that tie for the rest of the unit. We have a 5th degree polynomial. It's like x to the 5th of some kind, with a positive leading coefficient, so I don't have to put a positive, it's just understood as a positive. And that's it. So let's go ahead and begin. We have a possibility of 5 x-intercepts. Okay, again, it can be less because they can be imaginary, and I'll show you that here in just a bit. And then we could have 4 changes of direction, so COD, as I've been using. So now I'm going to show you these imaginary roots, okay? So let's work through the problem. It has a positive leading coefficient. That means it will go up as I go to the right. The fact that this number is odd shows that it will have an odd symmetry about it, okay? And then there are 5 possible x-intercepts with 4 changes of direction. So if I did something like this, let's do change of direction. Change 1, 2, 3, and we'll change 4. Okay, so let's say that we had a graph that looks something like this. I wanted you to see the variations. I do have 4 changes of direction. Notice the 4 changes of direction. I do have a positive coefficient. Notice that I go up as I go to the right. The 5 is an odd number, so that's why it shows it will not mirror, but instead do this odd symmetry about it. And then the last one is it could possibly have up to 5 x-intercepts. Okay, it doesn't have to, but it could. See, and this one has only 3. And the reason of it being is that where these could have dipped down and actually touched the x-intercept to make 5, they can in fact be imaginary. So this is just another variation that shows that this graph that I just drew could be correct. Now, if it had said that it had 5 real x-intercepts or solutions, then you would have to draw this to where it would dip down and then go back up, because the real solutions would be when it crossed the x-axis. But if it doesn't specifically say real solutions, you could have something that looks like this. Okay, yes, there are more variations of the possible graphs, but the big key points are what were highlighted as far as, is it a negative or positive coefficient, how many changes of direction that it would have, and that held true no matter what. If there were even or odd powers, okay, and then last but not least, what variations could exist with real or non-real x-intercepts.